current is a scalar quantity. You might be thinking that how it could be scalar when we know it flows from, the current goes from positive to negative. It is not because of that direction that we take it to be a vector, but because it doesn't follow the vector addition. Vector addition will come to you in class 11, so abhi ke liye just you can remember, because it doesn't follow that particular law. That is the reason it is not considered to be a vector quantity. Now next we come to a very important topic, that is potential. Now before you understand potential, we have to think, if you take a wire, right? In a wire there are so many electrons, and just now we said motion of electron give rise to the electricity. When you just take a wire and you just touch that wire, you will not get a shock. Why? Because no doubt electrons are there, they are moving, but that electrons, they are not moving in a particular direction. So remember, current is actually when the electrons, they move in a particular direction, then only we say it is current. If you just take a simple wire and you say, yeah, electricity is flowing through it, right? You cannot say that, because electrons being there, but they are moving in a random motion. So I need some device which is going to make the electrons move in a particular direction. So for that we say we have to generate the potential difference. We have to generate potential difference. Potential difference means that you need to create a difference in the electron on one side of the wire and electron difference on the other side of the wire, so that the electrons, they flow easily. It's just like if suppose you keep a tank on the top of your roof and you open the tap, water will itself come. You don't have to do any kind of work, it will come because of the gravity. Similarly, if we want to create the motion of electrons, you need to create the difference in the electron. Means on one side of the wire there should be more number of electrons, on the other side there should be less number of electrons, so that electrons go from more number to the less number till they become equal, right? So being thinking about that concept, we are going to start with our next topic. So before we start with this, it is the potential. What is potential? Because this term potential and potential difference is going to come again and again in this whole chapter. So what is potential? Suppose you take a positive charge, right? And you want to bring another positive charge from very far distance near to this positive charge. This work would be done by this charge. Some work has to be done. Why? Because both are positive, so this positive will not allow this to come near to it. So you need to do some work to bring this charge from here to this positive charge. Similarly, if suppose you have a positive charge again and you want to bring a negative charge from very far distance, infinity means a far distance, to this nearby positive charge. So what will happen? Because of their opposite nature, of course it would be attracted, so work would be done by the attractive force. In both the cases, whether you bring a positive near a positive or you get a negative near a positive, in both the cases the work is done. So what is potential? It is the amount of work done to bring a charge from infinity to a particular point. So in this case particularly, I am getting this positive or negative charge from infinity, means from very far distance to nearby this particular region. So that is said to be potential, and being the definition, the formula is work done by charge. So work done in getting a charge from infinity, this word infinity is very important, infinity to a particular point is said to be potential. And formula is work done by charge, and if you write the unit of work done, which is joule, charge is coulomb, so joule per coulomb, and this is said to be volt. Now just a small difference between potential and potential difference. See, when we say potential difference, like here I was bringing a charge from say infinity to a particular point. Now when I say potential difference, I am going to get a positive charge from a particular point to a b particular point. Means I know from where the charges would be going, from this particular point to this particular point. It's just like if you take the terminal of the battery or a cell, like this is a cell and the longer one is said to be positive and the shorter one is negative. So if suppose you want to bring a charge from this particular terminal to this terminal, we will say it is a potential difference. So what is the basic difference? In potential, you will say the charge is brought from infinity to a particular point, and in potential difference it is brought from a particular point to b particular point, means both the points are well defined from where you're getting the charge. And normally we usually deal with potential difference, not potential, because potential ke liye the thing is you are using the word infinity. Now I don't know from where exactly the charge is coming, so that is why we use potential difference when we know both the charges are coming from where, right? Now after that we are going to do the formula would be same. At a, the potential would be given by formula work done by charge, right? And at b it would be given by work done by charge again. So the formula would be you have to subtract both the potentials, va minus vb. So you are going to get the value of potential difference, and the unit would be exactly same, that is volt. Now after that, again, if you think, it is also a scalar quantity. Why? Because work done is a scalar quantity, charge is a scalar quantity. So yes, it is also a scalar quantity. Now next we come to a very important technical term, resistance. Before that, you should know how you measure the potential difference. We use a device called voltmeter. Just now I told you, like in the previous video, that when you are using AC, you must have seen a stabilizer having a device A or V. It's usually in the old stabilizer. The new ones are digital nowadays, so you might not see there. But if you have an old stabilizer, so there you can see a device written as capital A and capital V. So capital V is the voltmeter, which is going to tell you the voltage, right? We say voltage bata raha hai, so that is voltmeter actually. Okay, now next is, abhi just now I told you one thing, that if suppose you take say I have a wire, this is a wire, and I want that the current should flow in a wire, so I need the difference, I need to create a difference. So suppose if I attach it to a, say this is a cell, so this is a positive terminal and this is a negative terminal. So this terminal shows that there are excess electrons, this terminal shows that it has less number of electron. Positive means deficiency of electron. So now when you connect this particular wire with this battery or a cell, this is a cell in this case, what will happen? The electrons present here, they would be repelled, right? And they will start going forward. They would be pushed, right? Would be pushed forward. And because this terminal is positive, so electrons which are here, they would be attracted, right? Attracted means they would be going here. So what will happen? The difference would be created. Here the electrons would be pushed, here they are attracting. So this difference would be created in the number of electron, and that give rise to motion of the electrons, right? Okay, that would give rise to current. And you know the direction of current in this particular case, electrons move from negative to positive terminal, but the current sign is taken from positive to negative. So this arrow which I am showing is actually the motion of electrons, not the current. This is not the arrow for the direction of the current, but it is for the motion of electron. If you want to draw for the current, so the direction would be from, this is positive to negative, right? Now when the electrons, they move in a wire, what will happen? The move in a wire means I have applied, of course, the potential difference. That is the reason they are moving. Otherwise they don't move in a particular direction, they move randomly, right? Okay, so now when the electrons are moving in a particular direction, suppose this is a wire, it's not only a single electron which is here, but there are millions of electrons which are going to be drifted. I hope you understand. They would be pushed to go in a particular direction, right? Because here we have, say, a positive terminal, so all want to reach this positive terminal, right? So when they would be going forward, what will happen? They will collide with each other, and they will also collide with the walls of the wire, and due to what will happen, their kinetic energy will decrease. Kinetic energy will decrease, but the thing is, because there is a positive charge, although the kinetic energy will decrease, but still again they would start moving, they would be drifted, means they would be pushed forward. जस्ट उनको कह लो धक्का बजेगा उनको कि उनको जाना ही जाना है वहाँ पे, नो मैटर व्हाट, राइट? उनकी स्पीड कम हो ज़्यादा हो, बट दे विल डेफिनेटली रीच टू दिस पॉजिटिव चार्ज. सो रेजिस्टेंस इज व्हाट? resistance is the opposition to the flow of electrons, right? Resistance is the opposition to the flow of electron, because electron want to go forward, but the presence of this wire and the electrons and even also the positively charged particles, that is the nucleus, they will try to stop these electrons to move in the forward direction. So that is said to be resistance. So means if more resistance we have, what will happen? The current won't be generated more. So this is a basic diagram I've shown. Like voltage, I am showing that it is pushing the electron forward, right? But resistance will try to oppose them, right? So this is how you can remember. So resistance is the opposition to the flow of electrons. And yes, the symbol for resistance is given by capital R, right? Unit is ohm and symbol is this.